Assalamu alaikum. My name is Qasim Shehzad. Today we are memorizing lecture of mechanical technology from lecture number 3, that is equilibrium. Equilibrium is state is one in which all the physical properties do not change with time and are uniform throughout the system is called equilibrium. Then its type is thermal equilibrium. It is an equilibrium state where temperature is same throughout the entire system. Hot, for example, hot teacup put on the table. After a short period of time, temperature same with its surrounding. So the temperature that are same with its surrounding, so they are follow thermal equilibrium. Mechanical equilibrium, it is equilibrium state where no change in pressure at any point of a system with time. So this is must with time. Equilibrium state where no change in pressure at a point of a system with time, जिसमें टाइम के साथ एक पॉइंट पर प्रेशर में चेंज नहीं आता. अ पर्सन प्रेसिंग अ स्प्रिंग टू अ डिफाइंड पॉइंट. It is example working fluid. A matter contained within a system can be liquid, water or gas is called working fluid state. A condition of a system which describe its property is called state of a system. Now chemical equilibrium. Chemical equilibrium is an equilibrium state where volume of a system remain constant. Example is piston is fixed at one position of a system. Phase equilibrium, it is an equilibrium state of a system in which phase does not change with time is called phase equilibrium. Example is a system whose does not reach to its latent heat energy, that's why they cannot change its phase, mean same phase होगा. State postulate, it is stated that two independent and intrinsic properties are necessary to define completely the state of the fluid. Mean if you have want to define the state of the fluid, so you must have required two independent intensive property to define completely the state of a fluid. So this is called state postulate. Now pressure is force per unit area. Its unit is pascal. 1 bar is equal to 10 raised to the power 5 pascal or 100,000 pascal. 0.1 megapascal and 1 lakh pascal. And it is also 1 atm is equal to 101,325 newton per meter square is equal to 1 atm, or 101,325 kilopascal. 1 atm is equal to 1.01325 bars. Process किसे कहते हैं? Process is the property which does not change. Yeah, the property and state which does not change is called does not change. A property and state of a system which change with time is called process. Like so system have undergo a process or path. Any change that a system undergo from one equilibrium position to second equilibrium position or another equilibrium position. मीन अगर एक इक्विलिब्रियम पोजीशन से दूसरी इक्विलिब्रियम पोजीशन तक जाना है तो उसके दरमियान जो वे अपकमिंग आप करती है, इस वे को या इस रास्ते को या इस अपकमिंग को आप क्या कहते हैं? प्रोसेस कहती है. 1 किलोग्राम फोर्स पर सेंटीमीटर स्क्वायर इज इक्वल टू 9.807 न्यूटन पर सेंटीमीटर स्क्वायर. नाउ पाथ किसे कहते हैं? द सीरीज ऑफ स्टेट्स अपकमिंग व्हेन सिस्टम चेंज फ्रॉम इनिशियल टू फाइनल स्टेट. सो दिस सीरीज ऑफ स्टेट्स that are upcoming when you are moving from the initial to final state is called path. Cycle, sequence of process in which system begin and ends at same state. Mean ending point or starting point same होगा. No net change of state. Initial and final state are identical. जैसे example isothermal process किसे कहते हैं? Isothermal process is a process during which the temperature remain constant. Isothermal is a process during which temperature remain constant. जब टेम्परेचर कांस्टेंट होगा डेल्टा यू इज इक्वल टू 0, सो मैक्सिमम वर्क डन होगा डेल्टा क्यू इज इक्वल टू डेल्टा डब्ल्यू. आइसोबैरिक प्रोसेस. Example of isothermic process. Example of isothermic process is boiling of water at 100 degrees centigrade to steam. Another example is heat pump, refrigerator, melting of ice, condensation. These are the example of isothermal process. Isobaric process, the process during which pressure remain constant in a system, is called isobaric process. Example of isobaric process is the phase change process in which water boils and get converted into steam. जब फेज चेंज हो जाता है तो वॉल्यूम इसमें प्रेशर कांस्टेंट हो और आपकी हीट देने से फेज चेंज हो गया, तो इसको हम क्या कहते हैं, आइसोबैरिक प्रोसेस. लाइक डेल्टा क्यू इज इक्वल टू डेल्टा यू, यहाँ पर पी वी लग जाएगा. जब पी कांस्टेंट होगा तो डेल्टा वी किसके बराबर होगा, एन आर डेल्टा टी की. फिर है हमारे पास आइसोकोरिक प्रोसेस. आइसोकोरिक इज अ प्रोसेस which have in which specific volume remain constant. जब वॉल्यूम कांस्टेंट होगा, जब वॉल्यूम कांस्टेंट होगा डेल्टा क्यू इज इक्वल टू डेल्टा यू प्लस पी डेल्टा वी जीरो है तो ये जीरो हो जाएगा, तो मैक्सिमम इंटरनल एनर्जी चेंज आएगा. आइसोकोरिक प्रोसेस में मैक्सिमम इंटरनल एनर्जी चेंज आएगा, डेल्टा क्यू इज इक्वल टू डेल्टा यू. Now reversible process. Reversible process is a process is reversible if both the system and surrounding can return to their initial state. If both are coming to their initial states, so that are this is called reversible process. Every step of the path is at equilibrium with its surrounding. Every step of the path is at equilibrium with its surrounding. All processes occurring in nature are irreversible. No 100% efficiency occur. So due to friction, why all the processes in the nature are irreversible? Due to this reason. ड्यू टू irreversibilities. Irreversibilities क्या चीज़ है, factors that cause a process to be irreversible. Factors that cause a process to be irreversible is called irreversibilities. So due to these irreversibilities 100% efficiency is not possible. This is pressure difference, heat, collision, resistance, inelastic, rapid change, deformation, chemical reaction, temperature difference, expansion. These all are the factors that cause a process to be irreversible. Reversible process not actually possible. Then why we then why we are studying reversible process? So they are easy to analyze. They are used to make formulas, to understand well. So that's why we are using reversible process. Otherwise it is not actually possible, because 100% efficiency is not possible. Deliver the most and consume the least work. Criteria for reversibilities. When you want to make a reversible process, then you must have to make a care of these factors. Frictionless, different in pressure, have small. Process with slow, different in temperature is small. Work energy transfer, work energy interaction. So there are three ways in which work energy interaction occur. So the first one is rising piston, second is shaft rotating, and the third is electric wire in a system. Electric wire rotating in a system. So energy transfer by work done on the system would be positive, work done on the system would be negative. Heat supplied to the system would be positive, and heat rejected by the body should be negative. Heat and work are recognized at the boundary of a system. That's why they are called boundary phenomena. System have an energy, but they does not have heat and work associated with the process, because heat and work are not associated with the state. Heat and work are path function. Their magnitude depend on the path followed during a process as well as the end stages. So that's why they are inexact differential. Work done from integration from 1 to 2 into delta work done is equal to work done from 1 to 2. So work done is equal to force की जगह PA is equal to dx, dA और d की जगह delta volume change in volume, P into change in volume. So this is the equation of work done. Shaft rotating. Now when a shaft is rotating, so torque is equal to F multiplied by R. F की जगह क्या लग जाएगा, torque per unit R, और R की जगह या distance की जगह हम क्या लिख लेंगे, जैसा कि S divided by थीटा इज इक्वल टू S डिवाइडेड बाई R. सो S बराबर हो जाएगा थीटा R का. थीटा किसके बराबर है एक रिवोल्यूशन में 2 पाई R का, तो हम लिखते हैं कि 2 पाई R और n नंबर ऑफ रिवोल्यूशन. तो So work done is equal to 2 pi revolution, and this is torque. Phase and power substances. Phase is an homogeneous matter in chemical composition and physical structure. Phase is a homogeneous matter in chemical composition and physical structure. Mean phase are a substance in which a substance which have in chemical composition as well as in physical structure they are same. So this is called that these substances are in one phase. Like matter, all are solid, are all liquid, are all gases. So we say that this matter is a in phase. System that have only in one phase, oxygen and nitrogen mixed together form single phase. Oxygen and nitrogen mix together to form single phase because they both are the gases in a container. Pure substances, they have a uniform and unvariable in chemical composition, mean they are constant in chemical composition. इसका chemical composition constant होगा, more than one phase ये भी हो सकता है, लेकिन chemical composition इस phase में constant होगा. Steady flow process. Steady flow process is no change with time, a process during which fluid flow through a controlled volume steadily. Unsteady is greater change with time. An example is turbine, pumps, condenser, heat exchanger. Zeroth law of thermodynamics is two bodies are in thermal equilibrium and both have same temperature written if they are not in contact. Another example, another definition of zeroth law is if two bodies are in thermal equilibrium with the third body, they are also in thermal equilibrium with each other. So this is its example. Thermal, mechanical, kinetic, these all are the example of energies. Now temperature scale, measure of the average kinetic energy of each particle with an object. As also we know that temperature is the average kinetic energy of a particle. So different types of scales are ice point. So a mixture of ice, temperature scale बाद में discuss करते हैं. Ice point, a mixture of ice and water that is in equilibrium with each other at 1 atmospheric pressure and 0 degree centigrade temperature. At 1 atmospheric pressure and 0 degree centigrade temperature, a mixture of ice and liquid that are in equilibrium with each other is called ice point. Steam point is a mixture of liquid and water vapors in equilibrium with each other at 1 atmospheric pressure and 100 degree centigrade or 212 Fahrenheit. Now the relation between at 1 Kelvin temperature in Kelvin, when you are interrelated it, so temperature in Kelvin is equal to temperature in centigrade plus 273. Temperature in R is equal to temperature in Fahrenheit plus 459.67. Temperature in centigrade is equal to temperature in Fahrenheit minus 32,549. So these are the relation between different types of temperature scales. Absolute pressure, absolute vacuum pressure is the absolute zero pressure. Absolute pressure is the actual pressure at a given position. Pressure measured relative to absolute vacuum pressure is called absolute pressure. It is equal to absolute pressure is equal to gauge pressure plus atmospheric pressure. Gauge pressure, the difference between absolute pressure and local atmospheric pressure is called gauge pressure. Mostly pressure measuring devices are indicate gauge pressure because they show zero reading in the atmosphere. Vacuum pressure is below the atmospheric pressure, and a pressure in a vacuum is called vacuum pressure. Vacuum pressure is equal to pressure atmospheric minus pressure absolute. Now this is a manometer. This is the pressure measuring devices. When you have to find the change of the pressure, so you will have to take this rho gh and pressure atmosphere. Lifting of a large weight by a small force is the related to Pascal law. Yeah, it follow Pascal law. Pascal law is equal to P1 V1 is equal to P2 V2.